Hello, statisticians. Welcome back to our final lesson in our Unit 1 sequence. In this lesson, we're going to be learning to identify outliers using the interquartile range so I can make and interpret box plots of quantitative data. I'll know I've got it when I can use box plots and numerical summaries to compare distributions of quantitative data. We have I should say, of the what feels like an endless amount of vocabulary, standard deviation, which we talked about in the last video, variance, quartiles, interquartile range, five number summary, and box plots, which will be the main emphasis of today's lesson. So, back in 2017, our fearless president, Donald Trump, signed into law the largest tax reform in decades. And you might be wondering what this has to do with statistics and box plots. Stay tuned. So, according to Trump, his ideology was by eliminating tax breaks and loopholes, we will ensure that the benefits are focused on the middle class, the working men and women, and not the highest income earners. Supporters citing the statistic claim that the average income tax cut as a result of the law was 1,260 per household. Keyword here being average. On the opposite side of the aisle, we had Bernie Sanders, who very recently came out and said, "You remember just a few years ago when Trump and my Republican colleagues voted for almost 2 trillion in tax breaks for the wealthiest people in this country and the largest corporations." Critics of Donald Trump's law has state that the wealthy saw large tax breaks. Low income and middle income families didn't get much tax breaks to begin with. So, let's get ready to rumble and determine over the remainder of this video, did Trump's tax cut help the quote unquote average American? In order to do so, we need to first, once again, establish some prerequisite information. So here are the 12 salaries that we were working with predominantly in our fourth video. Before we determine which of these statements are true, we need to first establish what is a five number summary. When we have a box plot distribution, a five number summary begins with the minimum, that there, and maximum values. I'll place these up top. In addition, it includes the median, quartile 1, and quartile 3. So with that being said, though, right, the median value, since we have 12 numbers listed here, splits the data into two halves. So beneath the median, we have 50%. Above the median, we have 50%. So of these statements, right, 50% of all salaries are above 34,500. That is true. 50% of all salaries are below 34,500. That is also true. Quartiles are a statistical way of saying quarters. So the data that lies beneath 34,000 is roughly 3. I would say roughly is equivalently 3 out of 12, or 1/4, or 25% of the data. So if we're looking at 41,000, which would represent the value for quartile 3, that would be 75% of the data, right? We have 3, 6, and 9 out of 12 data values. So 75% of all salaries are below 41,000. Now, the reason we need to establish our five number summary is because up until this point, we've been relying on our intuition to determine what an outlier might be. Remember, outliers are unusually high or low data values. However, we need to transition into this space where we can accurately and statistically speaking validate whether or not a data value is an outlier. So on this slide, please respond and generate some discourse with your peers regarding whether or not you think $67,000 is an outlier. Once you make your selection, please explain your thinking before proceeding on to the next slide. Okay. As I said before, outliers are unusually high or low data values. To statistically validate if any data values are outliers, we must first calculate the interquartile range. If you've forgotten, the interquartile range is the difference between the first and third quartile in our data set. Next, using those statistics to determine we use the interquartile range to determine the upper and lower limits that determine if a particular data value can be considered an outlier. So in this case, right, translating that English into mathematical text, we have quartile 1, upper limit is quartile 3, brain fart, plus 1.5 times the interquartile range. And coincidentally, we apply very similar logic to establish the lower limit and determine if any of the data values exist beyond those limits. So for here, once again, the interquartile range is the difference between the first and third quartile. So that'll be a value of 41 minus 34. If you check your answers, you can see that my interquartile range is correct. So at this point, I would then take my quartile 3, which is 41, and add it to the interquartile range of 7 times 1.5, and I will obtain a value of 51.5. I can further verify that that is indeed the upper limit. So any values that go beyond 51.5, we would define to be an outlier. I'm going to leave the lower limit for you and ask that you conclude this slide by circling any of the values that you would consider an outlier statistically speaking. Next up, we have an oldie but a goodie, our box plots. Within a box plot, we have a few different visual images that pertain to the vocabulary that we've been regularly using. So first and foremost, let's start with our maximum and minimum values, but we have to be very careful here. Right, the maximum here. And obviously this leftmost dot would be considered the minimum. These arrows are pointing to two dots that exist beyond the box that we can see here in the middle and its whiskers. So those are pertaining to our outliers. Here, the box itself contains three critical pieces of information. We have, actually I should do this in math text. We have quartile 1 and quartile 3. The solid black bar is going to represent our median, and our curly brace encapsulates what you should recognize as the interquartile range. And box plots are a nice way to visualize our 5-number summary that we had conveniently expressed here. To draw a box plot, remember the following. Start at our lowest non-outlier data point. Right? This is our lowest non-outlier data point, not these two dots. Okay, this value of 2.5. Draw a whisker to quartile 1, box quartile 1 to quartile 3, with the median marked within the box, as we see here to our left-hand side. We are then going to draw a second whisker from quartile 3 to the highest non-outlier data point. It is very important that the box and its whiskers only encapsulate the data values that are not considered outliers. If we do have outliers, like we see here on the left-hand side, we're going to mark those outliers with points. On this slide, I would like for you to take the following words: symmetric, right skew, and left skew, and using your intuition, apply them accordingly. So if you think that the top box plot represents a symmetric distribution of data, leave the word symmetric there, so on and so forth with the bottom two. I'd like for you to also explain what it means if the data, about the data, if one of the whiskers is considerably longer than the other. I know, a lot of foundational knowledge. This is um, hyper compressed. All right. Using the salary data, I've generated a box and whisker plot that is not drawn to scale. So once again, note not drawn to scale. Using these particular markers, determine what percentage of the data lies below the first quartile. We addressed this earlier on in the video, so if you've forgotten, right, quartile is just a statistical word for quarters. So there should be approximately 25% of the data that is laying below the first quartile. Below the third quartile would represent another 25% on top of the median. So in total, that's a complete value of 75%. And I will leave the last three for you to work through. Here, we actually have a drawn to scale version of the box and whisker plot. Notice we follow our moniker title, salaries at a company, tick, tick. All our x-axes or our horizontal axes is ticked off, and then it is also labeled, labeled salaries and the subsequent values. Okay. There are a few different subtle nuances associated with describing distributions for box plots, and they include, for the shape, we're looking at the skew rather than modes. Let me make this text a little smaller. Beautiful. Okay. For the outliers, we're looking for dots. There we go. For the center, I hope you're thinking right now the word median, because if you are correct. And last but not least, the spread is going to be defined by the interquartile range. So, with that being said, how could we possibly describe this distribution? To do so, we can say that data was collected on salaries at a company, verifying the context. The distribution itself appears to be right skewed, right? The majority of my data is here, and then I have two outliers that are going to extend the tail of the data to the right-hand side, thus satisfying the shape. We can see that there are two high outliers at 67,000 and 185,000, taking care of the outlier portion. The median of the distribution is 34,500, thus verifying the center. And then the interquartile range is $7,000. So in this case, we definitely want to make sure that we take a nice systematic linear approach to describing distributions, considering that we know at this point 5. But let's return back to the main focus point of this lesson. So once again, supporters of Donald Trump's tax reform bill cited that the average income tax cut as a result of the law was $1,260 per household. Let's dissect this word average. I would like for you with your classmates to explain why we use medians and not means when describing center for a set of data shown in a box plot. After doing that, we need to also consider what kinds of tax plans could lead to an average tax cut of $1,260. Do you remember the phrase, no taxation without representation? If you don't, man, them history classes just be hitting different. All right, so here we've generated two different box plot distributions. I would like for you to compare these distributions of plan A and plan B. Be sure to use comparative language like less than, greater than, similar. This also applies when you're comparing dot plots, stem plots, histograms, and obviously Boxplots. The reason why I'm going to challenge you to come up with your own distribution is that this is the final video in the lesson sequence for Unit 1, and we need to start to sharpen and hone that confidence to accurately compare and contrast these distributions. Remember, CSOCs: center, shape, outlier, context, and spread. Now, of these shapes, which tax plan, A or B, shows tax cuts that benefit a broad swath of the American population? How can you tell? A broad swath just simply means more. Plan A or Plan B. However, they look extremely different. How is it possible that both of these distributions can actually have the same mean of 1,260? And at that point, let's skew it. So, information about the real distribution of tax cuts from the 2017 tax reform has been provided below. The data was compiled by the Nonpartisan Tax Policy Center. Describe why the following statements are misleading. Only the wealthy benefited from the 2017 tax reform. The middle class didn't benefit at all. The typical American household paid $1,260 less in taxes because of the 2017 tax reform. Note, $1,260 was the mean tax cut. And as always, make sure that you complete your reflection and synthesis slides. Those are what validate that you've actually watched my video and listened to me drag on endlessly about real-world topics. But with that being said, best of luck, statisticians, and I will see you in school.